All right, so this is chapter 2, section 4, and now we're going to talk about dividing polynomials. We're going to look at two different methods. First, we're going to look at long division, and then we're going to talk about synthetic division. Long division is the only method we have for dividing things, like example 3 on this page, where we have something raised to a higher power than 1. We can't use synthetic division for things like that. And so long division is something that we need to learn because there are times where we do have to divide by higher level polynomials. Synthetic division, once we practice it a few times, is quite a bit easier. However, we do still need long division for when synthetic division doesn't work. So let's go ahead and start in on some examples here. We are dividing x squared. X squared plus 10x plus 21. We're dividing by x plus 3. Okay. And let me just go on with some terminology here. This right here, this number underneath the bar, that's called our dividend. Okay. And this number right here is our divisor. Okay, that's what we're dividing by. All right, and now let's go ahead and start dividing here. So the question we're asking ourselves is x times what gives me x squared? And the answer to that would be x. And we want to make sure we keep things lined up here. Notice I have terms that are the same lined up above each other. So now we're going to say x times x is x squared. X times 3 is 3x. But we're actually subtracting. Okay, so I have x squareds that cancel. 10x minus 3x is 7x, and bring down the rest of it. And now we're asking ourselves, x times what gives me 7x? Well, 7. So 7 times x is 7x. 7 times 3 is 21. But again, we're actually subtracting. And we see that our 7x's cancel, our 21's cancel, and this is our remainder. So our remainder is 0. So what that means is that x plus 7 is our answer, and that is called our quotient. Okay, our quotient. Now, it might be helpful for us to actually recall what dividing numbers using long division looks like. So kind of off to the side here, I'll do a brief example. If I'm dividing 31 by 5, well, 5 doesn't go into 3, but 5 goes into 31 6 times. So 6 times 5 is 30. We subtract. We have a remainder of 1. So my answer would be 6 and 1/5. And we'll go through the same process with polynomials. So that's why we have the subtraction happening here. That's why we do the 6 times the 5, just like x times x gave us x squared. We're following the same long division process. Now let's move on to our next example. And notice that these terms are not in order. When we put them underneath here, they have to go in order. So we have 6x cubed minus x squared minus 5x plus 4, and we're dividing by 3x minus 2. So the question we're asking ourselves now is 3x times what gives me 6x cubed? Well, that would be 2x squared. So 2x squared times 3x gives us 6x cubed. And 2x squared times negative 2 is negative 4x squared. But we're subtracting. So those cancel, and I have 3x squared. Bringing down the rest, we have minus 5x plus 4. And again, asking myself, 3x times what gives me 3x squared? Well, that would be x. And x times 3x is 3x squared. X times negative 2 is negative x. But we are subtracting. Those cancel. I have, let's see here. Oops, this is supposed to be a 2x here. So I have negative 3x, bringing down the plus 4. And 3x times what gives me negative 3x? Well, that's negative 1. So negative 1 times 3x is negative 3x. Negative 1 times negative 2 is positive 2. But we're subtracting, cancel, and we are left with a remainder of 2. That's my remainder. So my answer then is 2x squared plus x minus 1 plus my remainder, just like before, my remainder was 1 and it went over what I was dividing by. So 2 over 3x minus 2. And that's my answer. Let's do one more, and this is going to have kind of a special scenario that I want to make sure that I point out. Here I have 2x to the 4th power plus 3x cubed, and I notice I don't have an x squared term. You have to put a placeholder term here. So 0x squared. We have 0x squares in this polynomial here. So there's our 0x squared minus 7x minus 10, and we're dividing by, let's see, x squared minus 2x. So let's go ahead and start dividing here. I'm asking myself, x squared times what gives me 2x to the 4th power, and that would be 2x squared. So 2x squared times x squared is 2x to the 4th power. 2x squared times negative 2x is negative 4x cubed. But we are subtracting, canceling, and I have 7x cubed, bringing down the rest. And now I'm asking myself, okay, well, x squared times what gives me 7x cubed, and that would be 7x. So 7x times x squared is 7x cubed. 7x times negative 2 is negative 14x squared. And so we're subtracting, so we switch those, cancel, and I have 14x squared, bringing down the rest. Okay. And now I'm asking myself, x squared times what gives me 14x squared? 14. And so 14 times x squared is 14x squared. 14 times negative 28x. And we're subtracting. So I have 28 minus 7 is 21x minus 10. And that is my remainder. So then my answer is going to be, my quotient here, 2x squared plus 7x plus 14 plus my remainder, 21x minus 10, over my divisor, x squared minus 2x. And that's my answer for this one. Now at the bottom of the page here, it says the division algorithm. Another term we have for this is called the remainder theorem. And what we're saying is that if I wanted to get back to my original equation, so if I wanted to get back to this equation right here, then my divisor times my quotient, so this guy times this guy, plus my remainder, this guy, would give me f of x. So if we wanted to work backwards. Now looking on the next page, we have synthetic division here. And I think what I'm going to do is stop the video here and we'll do a part 2 video. That way you guys can see these as 2 separate videos. So this will be the end of part 1 of section 4.